Modeling and simulation is a way that we can visualize things that might occur in the real world using either simulated data or real-world data that we brought in. You're either trying to understand the data itself or you're trying to get a better understanding of the environments. There's a few reasons you would want to model something visually in 2 or 3 dimensions. One is if you're trying to plan something, so a future event, and you want to see how the constituent parts may be working together. You may be feeding something in real time, so you have live data coming in and you want to be able to see what's happening as it's occurring. Or you might want to look at a past event, so you pull in data that was previously recorded and you can do some post-analysis. You can always have simulations without 3D representations. 3D just gives us a better visualization capability. There have been studies that show that having that added capability of seeing the environment actually allows people to make better, safer, perhaps faster decisions. Anything you can imagine in the real world that you might want to visualize is a great candidate for 3D modeling and simulation. It's all using a tool that you can apply to any problem set and trying to make yourself more efficient and effective. So if you're interested in having a career in modeling and simulation, there's several paths that you could choose. If you like data and what we call the back end, you might be interested in being a database person. So you would work with Oracle or SQL, making sure that you store the data, you can retrieve the data, it's secure.
The MAD Lab at Riverside Research stands for the Modeling and Application Development Lab. So we do a lot of the modeling and simulation work within the company. What I do is I support the back end of that, setting up the databases we use. There's a lot of analysis going on, so my job is to create the database structure to store all of that data so it's easily accessible, that it can be retrieved quickly, that it can be indexed. For instance, in the database, we might store things like all of our satellite attributes and characteristics of the users. You don't have to go in and make all those parameters. They can pull them straight from the database. In addition, we store data so it can be quickly retrieved and used in reports and graphs and calculations. This is geared toward making everything very accurate and set up for the analysts so they can really focus in on doing their jobs. To me, the best thing about working with the database is that I just love being able to, bring the data in and work with it and manipulate it in any way possible. And I love that it's so applicable to pretty much any area that you want to go into, whether it's modeling and simulation or anything else.
You might go into computer science, so you might want to be a software code developer, somebody that's making what we call the front end, the graphical user interface.
I'm a software developer. I write code that supports our efforts in the lab. The Systems Toolkit engine is a comprehensive package that you can use as an end user, but you can also write code which interfaces with that. Unmanned aircraft UASs are becoming more popular, and what we did was we adapted one of our existing products to use with that market. Basically, we plan the mission before the mission ever flies. After the mission's flown, we can collect the data, pull it back in, and then we can recreate and show those collections within the software tool. It's very complicated in terms of all the factors you have to put in. What we do is add a layer that makes that process more streamlined and easier to use for the people that actually use those tools. It makes them more productive, and it makes it easier for them to get a lot more data out in a smaller amount of time.
You could be trained on the software itself, so it might be initiating a simulation, it might be calling data that's been saved in a database. Then you analyze it, you see is this answering the question that we had, and then what decisions can we make from that?
I'm a senior human factors analyst. I work for Leidos Corporation. The job of analyst is really to answer questions. It begins when a customer comes to you with a particular question that they need to answer. And so the job of the analyst really is to take that question and translate it into an experiment. We use modeling and simulation to create that environment that we want to test in. We also collect data in that environment, so we use that data then to create an answer to the customer's question. While I'm an analyst, I don't work in a vacuum. We have a lot of software developers and database engineers, and so it's really kind of a team effort. I get to work with really smart people to solve complex problems. I like the fact that we compete to win the projects that we do. What is particularly satisfying is you get an opportunity to make a difference. We get to create products, solve problems that in the end keep people safe. So I love being an analyst.
I work for Riverside Research, and what I do is I test the software, I do some of the documentation, training materials, and help files, so when our users begin to use our products, they have an idea what they're doing. The way I got into the company was I started out as an intern, and I developed a project with Systems Toolkit. I liked using the product, I learned it pretty well, and then it helped me out with the products that we develop for our customers.
I'm a student at Sinclair Community College, and I am in the Aviation Technology program. I am working on Systems Toolkit on a scenario where we have a unmanned aerial system covering a forest fire.
I am in the Information Systems Security Certificate at Sinclair, and I have enjoyed working with Systems Toolkit because it gives you a broad spectrum from working with different scenarios, everything from cybersecurity related issues to UAS scenarios all the way down to something simple like communicating with firefighters in the field.
I'm an electrical engineering major at the University of Dayton. Over the summer, I was an intern at Leidos Corporation. The project that I worked on was developing a way to better collect aerial views within MetaVR, which is a virtual reality scene generator. One of the great things about MetaVR is that it's just cool. I was able to fly planes virtually all around the world without even leaving the lab. I'm still trying to figure out what I want to do, but working at Leidos has definitely sparked my interest in modeling and simulation. My internship allowed me to explore my love of science and math and see how I could apply them in career opportunities. The people that I worked with were experts in their field, and getting the opportunity to interact with them and work with them was really great.
In school, you learn a lot of the theories, you get a lot of the education behind this stuff, but the modeling and simulations allow it to really come to life for you, and you can really see what's going on. I think this field's just growing and growing.
There's actually degrees in modeling and simulation that you could pursue. Any career that you're really interested in will have some modeling and simulation component to it at some level. Pick the thing that interests you the most, and then you look at how you apply the tools and what you need to study.
If you pursue a career in modeling and simulation, you're going to get to be a part of projects that make people safe, that reduce the cost of products that are generated, and really get to be a part of creating the next generation high technologies, products, and capabilities that are going to shape the world. If you have a general interest in science and math, modeling and simulation is a great career field to look into.